Working with antibodies is such a pain, and now I have to go through the expensive process of determining antibody purity and concentration.
Sound familiar? Well, what if I told you there's a simple, fast, and cheap way to check an antibody's purity? I'm Amrita, and I'm here to tell you that this does indeed exist. Welcome to the exciting world of Coomassie purity staining. You know that working with antibodies can be pricey, not only because of the cost of materials, but also because you spend a lot of time checking the purity of your samples. You can perform a Coomassie purity stain with off-the-shelf, ready-to-use, and most importantly, inexpensive components. The process separates your sample by denaturing polyacromide gel electrophoresis, alongside serial dilutions of a standard antibody to determine the concentration. Once your sample is stained, the protein band intensities are measured using ImageJ software and a standard curve is generated. The ratio of the antibody protein content to the total protein content of the sample is determined. Have I sold you yet? Excellent. Now it's time to get your materials together. You'll need a fume hood to work in, a heat block, pipettes of varying sizes and corresponding pipette tips, a pipette controller with disposable pipettes of varying sizes, microcentrifuge, an electrophoresis chamber and power supply, a metal spatula and maybe a razor blade, a rocking platform, plastic tray, gel imaging system, ImageJ or similar software, microcentrifuge tubes, and some sterile deionized water. Got your supplies together? Now it's time to get the reagents. You'll need your purified recombinant antibody between 0.9 and 1.1 megs per mil. Remember, this concentration could contain the antibody and other proteins and debris. We're trying to determine the final concentration with this protocol, which is just the antibody. A Coomassie stain, like Simply Blue Safe Stain. A 4 to 12% Biz Tris mini gel, 20x MOPS SDS running buffer, 4x sample buffer, and 10x sample reducing agent. You'll also want a pre-stained protein ladder and then your usual suspects in PBS and deionized water. And you'll need an antibody isotype standard at about 2.5 megs per mil. You can use a commercial standard or validate an in-house standard if you prefer. Wrangled everything you need? Perfect. Now I know I said this is a quick protocol, but even a quick protocol requires some prep. Here are a few things to do before you begin. First, warm your hot plate to 100 degrees Celsius. While it's warming, put your antibody standard and pre-stained protein ladder on ice to thaw. Once your antibody standard is fully thawed, we'll use it to make a serial dilution PBS for our standard curve. Starting with the 2.5 meg per mil antibody standard, dilute as follows. After you've finished preparing the antibody standard, transfer 5 microliters of each standard to a microfuge tube. Now add 8 microliters of PBS to a total volume of 13 microliters per tube. Now that we have our standards, we'll need to get our recombinant antibody ready. It needs to be at a concentration between 0.9 and 1.1 megs per mil, so dilute or concentrate as necessary. Grab your next microcentrifuge tube, which should have 8 microliters of PBS, and add 5 microliters of your appropriately concentrated recombinant antibody, mixed by pipetting. Finally, you'll need to prepare your 1x MOPS buffer. Dilute 50 milliliters of 20x MOPS buffer into 950 milliliters of deionized water, cap the bottle, and gently invert to mix. All right, that's the prep work finished. Now it's time to get down to business. Staining business. We'll start with our SDS page. First, add 5 microliters of 4x sample buffer to each sample standard. Then add 2 microliters 10x reducing agent to each sample. Give the tubes a quick spin in the microcentrifuge. Once that's done, heat the samples for 10 minutes at 100 degrees Celsius at a heat block. Then pop them into the microcentrifuge for another quick spin. While the samples are cooking or spinning, let's prepare the gel. You'll need to remove it from its plastic wrapper and then rinse with deionized water. Some people find it easier to remove the comb and rinse the wells now. We prefer to do it after we've placed the gel in the chamber. After the rinse, gently and carefully remove the white sticker from the bottom of the gel. Place the gel in the electrophoresis chamber and secure it. If you're unsure about the correct orientation of the gel, be sure to check the manufacturer's instructions. Once secured, carefully remove the comb from the top of the gel if you haven't already, and rinse each well with 200 microliters of 1x MOPS running buffer. Then fill the chamber with the 1x MOPS running buffer. Now load 5 microliters of the pre-stained protein ladder to the appropriate well. Next, you'll load 20 microliters of each sample and standard into the gel. If possible, skip one lane between the protein ladder and the sample. Leaving clear lanes between samples will make quantifying the gel easier. Cover the electrophoresis chamber and attach it to the power supply. Run the gel at 150 volts for 1 hour. Keep an eye on your gel and remember, no smiling. If the samples are starting to form a pattern that looks like a smile, go ahead and reduce the voltage. Once the gel is finished, turn off the power supply and unplug the electrophoresis chamber. You don't want any unexpected zaps. Next, remove the gel from the chamber and use a metal spatula to gently break the gel cast open. Once free of the plastic cast, use your spatula or a razor blade to cut the top of the wells and the bottom part of the gel, where dye is visible. Okay, we've sliced, we've diced, and now it's time to get staining. Place the gel in a plastic tray with 100 milliliters of deionized water. Rinse the gel with the deionized water for 5 minutes with gentle agitation on a rocking platform. After the rinse, pour off the water into the sink, being very careful not to pour out the gel as well. Now add 20 milliliters of Simply Blue Safe Stain and incubate it for 1 hour with gentle agitation. After incubation, pour off the stain into the sink. To rinse off the excess stain, add 100 milliliters of deionized water and incubate again for another hour with gentle agitation as before. And for the last time, water out, gel in. Fire up your imaging system of choice and take a bright field image of the gel. Keep a couple things in mind when looking at the gel. First, most recombinant antibody preps should have 2 clear bands at about 50 kilodaltons and 25 kilodaltons corresponding to the heavy chain and light chain proteins. There should be very little background staining. Second, a large shift in the electrophoretic mobility of the bands indicates that the samples may not have been processed correctly in the cell. For example, there may have been a failure to cleave the signal peptide. These proteins may not be fully functional. This sample would require additional tests to ensure functionality. But if you have 2 bands in the correct place with relatively low background, assuming that's what you're looking for, which will be the case most of the time, you're ready to analyze your image. For the analysis, you'll need to use ImageJ or a similar photo software to determine the relative intensity of the protein bands compared to the overall lane. First things first, you'll need to import the file. Select File, then Open, and choose the file's location. Next, you'll need to change the image type to 8-bit. Select Image, then select Type, then choose 8-bit. Now you'll be determining the lanes of the gel for the software 1 lane at a time. Start by selecting the Box tool and draw a box around the entire first gel lane. Then select Analyze, then Gels, then select First Lane. Now drag the box to the next lane. And select Analyze, then Gels, then select Next Lane, and so on and so forth for your remaining lanes. It may be useful to memorize the keyboard shortcuts for this. Now you can plot the curves for the protein bands. Select Analyze, then Gels, then plot lanes. 1 graph per lane will appear with peaks representing each protein band. Use the line tool to connect the bottom of each peak. Once finished, select the wand tool and fill in each peak by selecting its center. Now you'll need a file type you can open in a spreadsheet editor, like Microsoft Excel or Google Sheets. Select File, Save As, name your file, choose the destination, then click Save. See? It's so simple even bacteria could do it. Oh, sorry, Blue Jean. Your final step is determining the percent purity of your samples using math. Fear not, biologists, this is an easy formula. Your percent purity is equal to the area of the heavy chain plus the area of the light chain, derived by the sum of the area of the bands times 100. Ah, the moment we've all been waiting for. Spreadsheets. I can hear it now, the sound of thousands of clicks as viewers abandon ship to the nearest cat video. I can wait. Great, you're back! The good news is, modern spreadsheet software makes these calculations incredibly easy. At Addgene, we typically use Google Sheets from the lab, but most spreadsheet editors function similarly. First, you'll need to plot the megs per mil versus the heavy chain and light chain area for the IgG standards. So open up your exported CSV. You can format the spreadsheet as you see fit to make the following calculations easier. Now select Insert and Chart. This will add a blank chart to your spreadsheet. In the chart editor, click the chart type dropdown and select a scatter plot. Now change the data range and select the cells where your x-axis is represented. Next, click the Customize tab, select the Series dropdown, and select Trend Line. Next, you need to determine the linear equation and r² of the trend line. Select the Label dropdown and select Use Equation. Then click the Show r² checkbox. The r² of the trend line should be between 0.95 and 1. Now use the data you've just gathered and plug it into the concentration equation we've just derived. For example, if the sample heavy chain area plus the light chain area is around 18,000, and the linear equation of the standard curve is as shown on screen, then use the following formula to calculate the concentration of your sample. And just like that, you have your antibody's purity and concentration. Easy, right? You know what else is easy? Checking out Addgene's other video and written protocols on topics like antibody purification and the dreaded Western blot. Visit addgene.com/protocols for more, and subscribe to our YouTube channel to get more protocols as well as other educational content. Addgene, a better way to share science.